How might we use a random digit table to simulate each of the following? So, first off, tossing a single die. So how can a random digit table help us do that? Well, here's the options down here. So tossing a single die. What are the answers going to be here? Let's read through the various possibilities. Let 1, 2, 3, 4, 5 represent the numbers on the die and ignore the others? No. A die has 1 through 6, right? A die has numbers 1 through 6. That's not going to work. Let 1, 2, 3, 4, 5, 6, 7? No, it's just 1 through 6. 1 through 6 represent the numbers in the die. Ignore the others. Yeah, that would work. That would work great. So if you wanted to use a random digit table, so that would be just a table that has tons and tons of digits in it. You would need to just use 1 through 6 to represent the numbers that can happen when you roll a die. You know, like a die, a single 6-sided die. It's not a very good picture. Let me try again. Here, it's looking much better. There we go. Yeah, so there's a die. It's got, the 6 numbers on it. And so if we roll that, it's got 6 sides, so we'd need the 6 numbers 1 through 6. So next question. Which is a way to use a random digit table to simulate choosing 3 people at random from a group of 20 people? 3 people at random from, so if you have 20 people, so if you're wanting to simulate, so we're talking about how you can simulate. It's a lot of what we do in the world of probability. We simulate a real life situation with a random digit table, which means a big table of a bunch of digits. So if you have a big table with a bunch of digits, how can you simulate a real life situation of choosing 3 people at random from a group of 20 people? You have 20 people. What could you do? Well, let's go through the possibilities. Is it A, number the persons 0, 1, 0, 2, 0, 9 up to 10? No, there's 20 people. No. B, number the persons 0, 1, 0, 2, 19 all the way to 20. Yeah, you have to, you'd have to have your 20 friends and assign them all a number from 1 to 0, 1, 0, 2 all the way to 20. Go to the random digit table and mark off groups of 2. Take the numbers in groups of 2. The three persons chosen are the first 3 whose numbers appear. Yeah, that's exactly right. That's what you would have to do. So, so if you had like 7, 8, 6, 3, 1, 4, 2, 9, 8, 5, 0, 6, 3, 9, 1, 8. So let me give you an example. So suppose you just have a bunch of random digits. That's all a random digit table is a bunch of random digits. You would mark them off in groups of 2s, like this. Okay, then you'd go to and you're looking for the numbers 0, 1 through 20. So you look at the first set, 78. No, that's not even in our zone. That's not a number 1 to 20. 63, no. 14, there we go. So the first friend chosen would be friend number 14. Next, 29. No, that's not even between 1 and 20. 85, no. 06, then friend 6 is chosen. That's in our zone. Next one. 39, no, it's not even between 1 and 20. 18, yeah. So there's the 3 friends. Out of our 20 friends, we picked friend number 14, friend number 6, and friend number 18. Make sense? That's what B is saying. Break your numbers into groups of 2, and just start going until you find 3 numbers out of this set. That's like picking 3 friends out of 20. It's a way to simulate that. Okay, and then part C here, the third part, which is a way to use a random digit table to simulate spinning the spinner. So what spinner? So they got this spinner up here. Notice the white is 0.1 or 10%, same thing, right? Decimal or percentage. The yellow is also 0.1 decimal or 10%. The green is 0.3, the red is 0.5. So that means out of 10 digits, red is going to have, we're going to use a random digit table to simulate the real life activity of spinning this spinner. See this spinner right here? We're going to spin this spinner around, let it go round and round and round, and want to find out what region it lands in, red, green, yellow, or white. Well, that's the same thing. You could simulate that by going to a random digit table and giving 5 digits out of 10 to red, that's 0.5, 3 digits out of 10 to green, that's 0.3, 1 digit to yellow, 1 out of 10, that's 0.1, and 1 digit out of 10 to white, because there's 10 digits, right? 0 through 9 is 10 digits on a random digit table. Every digit could be 10 different things. So, coming back to the question, it's going to be represent the red by the numbers 0. No, that would be 6 numbers. Red's only supposed to get 5. No. Represent the red by 0. No, that's only 4 numbers. Red's supposed to get 5. Represent the red by 0 and 1. No, that's only 2 numbers. Red's supposed to get 5. Represent the red by 0 through 4. Yeah, that's 5 numbers. Green has 3 numbers. It doesn't matter which 5 numbers or which 3 numbers. As long as green gets 3 numbers, then he has a 0.3 chance of coming up, just like the green in the spinner has a 0.3 chance. He occupies 30% of the area of the spinner. So if you give him 30% of the digits, 3 out of 10 digits, give red 5 out of 10 digits, give yellow 1 digit, and give white 1 digit, then they'll each have 0.1, 0.1, this will have 0.5, and this will have 0.3. That's the right answer.